Hello friends, in this video, let's have a look at problem 1758, minimum changes to make alternating binary string. So actually we just solved explained problem 2597, in other words, this problem. Then we come here to look at this one. So this problem is marked as easy by leetcode. However, this is a very interesting one. And also, indeed, it's rather simple because we know the result, the possible results of, or more precisely, the possible resulting strings. So in this video, first we are going to digest the requirements, and then we come up with a solution which uses O of n space complexity. Here n is the length of S, and then we are going to explain how to improve it to be O of 1 in space complexity. So now let's look at the requirements. So here we are given a binary string, and in one operation we can change 0 to 1 or vice versa. In other words, you can choose any index and then flip the corresponding string character there, 0 to 1 or 1 to 0. So the string is called alternating if no two adjacent characters are equal. So here is one that is alternating, and this guy is not. So we want to find the minimum number of operations needed to make S alternating. So here we have 3 examples. So you can see the first one, you just need to change the last 0 to be 1. So that's the output 1. And 1 is the number of operations, right? The second one is already alternating, so we output 0. So for the third example, because all the characters are 1s, so we just need to alternately change flip. So for example, we change the first one to be 0 and the third one to be 0. Then we need 2 operations. Equivalently, we can change the second one and the fourth one to be 0. So also 2 operations. So here the constraints are the following. So we know that the length is bounded above by 10 to the power 4. But this 10 to the power 4 actually is not that large, because if you consider time complexity, typically for such a length, and square time complete solution will typically not pass all the test cases. And the second operation basically emphasizes that the string is a binary, right? So now let's look at the analysis. So this problem actually is easy due to the fact that we can know the possible resulting alternating strings, right? So here the strategy, I would say, think of the resulting alternating string. So there are only 2 possibilities, right? The result, resulting string, alternating string, either 0, 1, 0, 1, or something, right? Depending on if you have 1, 0 or not. In other words, this is related to the length. If the length is even, you just have a repeat or multiple of 0, 1s. If it's odd, so you have additional 0. Or you have 1, 0, 1, 0, 1, 0, 1, 0. Then depends on if the length is odd, you have another 1, right? Then we just need to compare the different positions of the original string S with either this one or this one. And then we just need to return the minimum 1, right? So that's the main logic. So first, let me code one solution format so that we know what we are talking about, right? So we know the length is m, right? So now let's initialize the 2 possible alternating strings. So here I'm going to repeat 0, 1 this number of times, that is n over 2, right? So then if you the length is odd, so I'm going to add an additional 0, right? So this is nothing but n modulo 2, right? So if n is even, so this is nothing empty, right? If n is odd, you add a 0. So similarly, I can copy this line and alternating 1, 0, right? 1, 0. And then here, I'm going to change this one to be 1, right? And then we are going to consider if we change S to be S1, so how many operations we need. Then if I change S to be S2, how many operations we need. So now let's see, P1 is, let's do a summation. 1 for I in range n if si does not equal to s1i, right? So we have this one. So now let me copy this part again, and we do the same thing for s2. So we get p2. So this is s2, and then we are going to return the minimum of p1 and p2. So let's first do a test. So this passes 1. Now let's look at generic case. Yeah, it passes all the cases. So now let's get a quick walkthrough. For example 1, so we have s is length 4, right? So we possible alternate string will be 0, 1, 0, 1, or s2 1, 0, 1, 0. But we know s is the 0, 1, and 0, 0. So if we want to make s and s1 equal, so we know there are only one different positions, that is the last position. So we know we need one operation, and the resulting substring will be s1. And then if we want to make s to be s2, so there are 3 positions different, then we get s2. Then the minimum of 1 and 3 is 1. So in this problem, we're going to return 1. So now if you look at x is 3, so you get length is also 4, but here s is 1, 1, 1, 1. So if you want to make this s to be 0, 1, 0, 1, you need 2 operations, right? So 2 operations result in s1. But if you want to make it to be s2, the same, also 2 operations, right? So you also get 2. So the mean of 2 and 2 is 2, right? So, but the resulting one can be either s1 or s2. In this case, it coincide. So this is the one operation, one coding format. But if you look at the time complexity, for sure it's O of n. And the space complexity is also O of n. You know, here I use this s1, s2, and also this one. But if you see that we don't need to, in order to get these numbers, we don't need to first have s1 and s2. We just need to use a start, right? It's 1, see, then we alternating, right? Alternating. Then 0, 1, 0. How do we realize this alternating? We just need to use, say, 1 minus start and update it to start, right? So if your start is let's see, is 1, so after you update, so you get 0, and if your start is 0, then you get 1. So if you start from you can this way we can treat the 2 cases in one go. So this way we can make this coding O of 1. Now let me copy this part. So I'm going to translate the above thought process into the coding format. So this is actually rather straightforward. So I'm going to use the current. So this is the representative start. We want to consider strings, targeting strings starting from both 1 and 0. But this variable will be this single variable will be sufficient. So now I want to see n operations. Let's record n operations complement. So let's set them to be 0. So let's assume n operations count. So if we want to append a string starting from 1 and alternating how many operations we need, and the other starting from 0, or vice versa. So actually, we don't need to strictly distinguish these two, right? So we just need to do it consistently. So for I in range n, right? Let me don't use this n. That's s. Then what we are going to do? Let's see. I want to this one. Recording the number of operations needed to make it say 0, 1, 0, 1, 0, 1, right? So we want to increment by absolute value, say s integer s at index I, then minus so current, right? So then the other one, I'm going to do increment ABS, and let me just copy this. This is similar, but I use once alternating, right? So here I change this one to be 1 minus current, right? Then afterwards, if for next round, we're going to do iteration. Anyway, we're going to do current equals 1 minus current. So then we just need to return the mean of this n operations and n operations complement. So this actually is the same code as the version v1, but we can regard it that we simplified the first version, or we can think we start from slightly different thought process, right? So now let's do a test directly. Yeah, it passes all the cases. So now that's basically about it for the coding part. So here in this video, so we first used the fact that we can envision the resulting alternating string, right? There are only two possibilities. And then we compute the number of operations to arrive at those two possible alternating strings. And then we return the minimum of the two number. And then we improve this code from space complexity O(n) to constant space time complexity. I guess that's also the main point for this video. So with that said, I guess that's about it for this video. Thank you.